Okay, in this question, we need to show that 3x squared plus 2kx plus k squared plus 2 is positive for all real values of k. Before we begin, let's take a look at the previous question and its solution. This will allow us to compare the problem-solving strategies better. Okay, so in the previous question, we have to find the range of values of k for which x squared plus 2x plus k minus 3 is always positive. So these two questions actually look quite similar at first glance. In the previous question, what we did was we used the graph of y equals to x squared plus 2x plus k minus 3 to help us visualize. So for this expression to be always positive, we need this graph over here to lie entirely above the x-axis like this. So this is what we want. We want the graph to lie entirely above the x-axis. So if this holds, we also can observe that this graph does not cut the x-axis at all. So if it does not cut the x-axis, we know that the discriminant b squared minus 4ac is less than 0. And using this, we can just do the substitution and find the range of values of k. So we just substitute b is 2, a is 1, and c is k minus 3 inside to find the range of k. So now let's go back to the new question. So like I said earlier, these two questions look quite similar at first glance. So many students will actually do this. They will assume that the condition y equals to 3x squared plus 2kx plus k squared plus 2, that this graph lies entirely above the x-axis. They will assume this to be true. So with this being true, they will then say that the discriminant b squared minus 4ac is less than 0, and so on. But let's not do this. This method is actually wrong. So what is wrong with this method? In this question, we are supposed to show that 3x squared plus 2kx plus k squared plus 2 is positive. We are supposed to show this. So we cannot actually assume that this condition is true. We cannot assume that the graph lies entirely above the x-axis. We have to show this, not use this as assumption. But in the previous question, we can do that. This is because in the previous question, we want to find the range of values of k such that this condition holds. So the question really tells us that this condition holds. Find the range of values of k for me. So how should we approach this new question over here? Okay, so what we can do is we can actually calculate the value of the discriminant b squared minus 4ac first. So discriminant b squared minus 4ac is equals to, I'll do the substitution, and after substituting I get this, and after simplifying I get this. This is a very crucial step, because once I have this, I can actually say that since k squared is greater than or equals to 0, so k squared is greater than or equals to 0, I have minus 8k squared is always less than or equals to 0. And if I'm going to subtract 24 from this minus 8k squared, then this expression minus 8k squared minus 24 has to be less than 0. Since this expression is the discriminant, we can say the following: that the graph of y equals to 3x squared plus 2kx plus k squared plus 2 does not intersect the x-axis. So using this discriminant, I make this conclusion. Instead of I start with this conclusion, and then I say that b squared minus 4ac is less than 0. Okay, it's different. So we can make this conclusion after calculating that discriminant b squared minus 4ac is less than 0. Okay, then we also say that the coefficient of x squared is positive. So the graph opens upwards and the graph looks like this. And then from here, we can conclude that 3x squared plus 2kx plus k squared plus 2 is positive for all real values of k. And then we are done.